Hi, Algebra 2 kids. This is Dr. Callahan for week 10 Thursday, and we're almost for spring break or to spring break. So go ahead and pause the video and answer the following 3 questions. You guys should have 12 boxes filled out since this is week 10 Thursday, and you guys just got a brand new warm-up log on Monday. So this has been 4 days, so 4 times 3 boxes a day is going to be 12 different boxes filled out. All right, you guys, go ahead and take a look at your question number 3. Your answer is negative 6x cubed plus 3x squared minus x minus 4. Unfortunately, it's not Friday yet. I'm sorry, but tomorrow we will have that. All right, so spring break is within the horizon, and given the fact that this is an algebra class, I talked about spring break trends and statistics because it is a math class. And so here are some statistics. If you take a look at the regional trends of spring breakers, this is where everybody's going to be going. 19% of people in the West will spend less than $500 for spring break. In the Midwest, 75% of them will stay in the US. In the South, 37% will travel between 10 to 500 miles. And in the Northeast, like New York, they're going to head towards the Sunshine State, especially with how cold everything is. Majority of people just tend to go to Florida for partying and whatnot. This is the average spring break cost for hotels. And as you guys can see, Florida, New York, they tend to be the more expensive ones, also in Mexico. And then the growth percentage over the last 5 years of emerging popularity with among spring break locations, Panama City is definitely up there. Dominican Republic, Mexico seems to be a very popular area. A lot of people tend to go to Florida to go on cruises for Mexico. These are some additional statistics. So these are the top destinations. About 40% will go to beaches, 20% go to big cities, 11% go up to the mountains, 6.2% goes camping, and then 6% of people will travel internationally. Spring break is a $1 billion per year industry, so people spend a bit of money. The average college students will spend about $1,100 for the week-long trip. And the number 1 spring break destination is Panama City, Florida. 95% will share a hotel room with friends. 12% will be staying over in a room with 7 people. I'm like, that's a little bit crazy, but I guess you got to do what you have to do to save money. These are some of the popular destinations in America. Again, Florida seems to be the really popular one. A lot of people in the Northeast right over here, because especially with the really horrible storms they've been having with the cold chill and everything, they want to go to warmer weather areas. People like to go up to the mountains over to, like Grand Tetons or Yellowstone in Montana. Some people go down to Arizona, Colorado, Texas, and then Georgia. But mostly Florida. All right, you guys, let's go ahead and get started with today's stuff. If you were not here last class, what you missed was that we did a pie line skyline for our Pi Day celebration. And so some of your work is like showcased outside. Also, we took your quiz for this week, and it is on Math Excel. It is labeled as week 10. Wednesday. And so if you were not here yesterday, that's what we did. And also we worked on your Math Excel assignment for practice on properties of exponent and radical functions. And so these are the 2 things that we went over yesterday. In addition, your grades are updated. It's posted on Teams, and it's also on Infinite Campus. So you can see whether your grade went up, down, or if it remained the same. Keep in mind that if you're here on a regular basis, which is awesome, but you're simply just sitting there and not doing anything, I won't give you 50% because that's saying like you're not even here at all. But the most you'll get is 55%. You need to have a 60% obviously to pass. And remember, your safety grade for this class is a 75%. And that's the balance with your final, which is 15%. And it's not an easy final. It's not my final. It's the common district final. So just like in geometry and algebra 1, like 1 year ago, you guys have a district final. And so if you, let's say, fail that final, you get an F. 75 minus 15 is still a 60%. So you'll still be able to pass the class. If you don't pass this class, next year going to senior year, you'll have to take like either algebra 3 or Prob and Stats, which are the two classes you guys probably have selected. Some of you guys decided to go to trigonometry and pre-calculus, and then you will also have to take Algebra 2 as well simultaneously. So you have 2 math classes there for next year. So just kind of think about that. There is absolutely no curve on the final, and that's not my decision. That's a decision from Washoe County School District. So out of the 13 high schools, all juniors who are taking Algebra 2, you guys have the same task and there is no curve. And it's a very, very difficult test. 2 weeks before the test, I will go over the study guide with you guys, and I'll go over them specific one by one. There's probably like 50 questions on there. I won't go over all 50 questions to get you guys prepared for the test. But again, it's a really hard test, you guys. Not only do you have to know like Algebra 1, Algebra 2, but then also you have to know how to use your calculators. And that's why I've been like integrating calculator usage in class. So that way you guys get the exposure. So that way you're ready to go on to take the test. And then also, you know, for future math classes as well. All right, so with that said, let's go and take a look at your YouTube channel for this class. Yesterday, I have your stuff here. So let me go ahead and switch it over. Oh, you know what? I need to convert the one from yesterday. So once this is done converting, I will post the video on from yesterday, which is week 10, Wednesday. And you guys will have that on there. But right now, you guys currently have 44 videos, and everything that we've done since Monday and Tuesday this week is there. Wednesday, I'm converting right now. I'm just going to upload it, so we have that there as well. So if you miss any of the classes, you guys, make sure you're watching the videos and then doing the work and then just turning it in so that way I can replace your grade with a better grade. But that's generally how you make up things in class. I don't give out extra credit mainly because it's like, if you just do the work I videotaped for you, you just do that, then you should be fine. You know, you don't have to be super good at math to pass this class, but you, however, need to just do the work. All right, so with that said, let's go ahead and take a look at our skills. We've already done skill 1. We've done part of skill 2. And we're going to continue on with skill 2 today, okay? In terms of where we should be for your calendar, we are right here for Thursday. So let me just move that over by 1. And so today we're going to talk about properties of exponent and radical functions. Oh, hold on a second. That didn't move. Hold on a second. Why is this not moving? Sorry, just give me 1 second. Yes. Yeah, go ahead and sign out, my dear. Okay, now it's moving. I don't know why it didn't move before, but I was like, that's kind of weird. So properties of exponent and radical functions. Tomorrow's Friday, which is the day before spring break. We'll finish up that. And then you guys have 2 weeks of spring break, okay? Then when you guys come back, we'll start graphing radical functions and moving on to functions and operations, solving radical functions, inverse relation functions. And then the last day for this will be on April 15th. And then we're done. We're moving on to a new unit. But yeah, it's kind of nice to have a calendar so you can see what the next step is. All right, so today you need to have my guided notes that I'm going to be handing out to you guys. We're going to continue our Pi Day celebration at the very end. And then I have like an escape room on exponent rules edition. So you guys need to have your, grab an iPad and cell phone. You need to have your TI-84 calculator, and then just the handout from Dr. C, or same handout. That handout will be turned in before you guys leave today. So make sure you guys complete it within the allotted time in class, because you will not have additional time to do that after. So come on up, you guys. I have the paper that you need right here. Yeah, the TI-84 is on the very bottom. So have So take a look over here. We're gonna get started on this page for you guys. And let's get started right over here. Okay, so perfect squares. If you do not know these, commit to memorizing them now, and I'm gonna label them for you. The perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So those are the most common ones. And if you're like, really, why are they perfect squares? Because if you square root them, what they're going to equal to is a square root of 4 is a 2. Square root of 9 is a 3. Square root of 4, or the 16 is a 4. Square root of 25 is a 5. Square root of 36 is a 6. And I think they kind of see the pattern, right? It's like 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. If you go down over here, this one's 11, because 11 times 11 is 121. And then, of course, 12 times 12 is 144. And that's the pattern there. If you're not sure, you can always use your calculator. Go ahead and type that in. By your answer. All right, so let's go ahead and take a look at example number 1. Example number 1, you have a square root of 225. That's not going to be perfect. So you got to ask yourself, okay, what two numbers multiply together, one of them being perfect, gives me 225. And this is where you grab your calculator. You can use your calculator on the test. So of course, I want you guys to use it to your advantage. So what I will do is I'll just put 225 and go, does 4 go into 225? Does 9 go into 225? Does 16? Does 25? Does 36? Any of those perfect numbers go into 225? And which one do you think will be a number that goes into 225 perfectly? I don't know about you, but because it's odd number, I would think 25 would. So I'm just gonna divide it. So if you divide it by 25, 25 times 9 gives you 225. So I'm just gonna put 25 and 9. And then what is the square root of 25? You guys know that's a 5. What's the square root of 9? That's a 3. So what's 5 times 3? 15. All right, let's go ahead and take a look at 24. For 24, you're going to ask yourself, what times what gives me 24? But one of the factors is going to be a perfect square, like 4, 9, 16. Well, given the fact you have 24, you don't want to use 36. So that number's too big. So it's either going to be 4, 9, or 16. So I'm just going to do 4 because they're both even numbers. And I know 4 times 6 is 24. So I'm just going to put 4 and 6 in square root. And with this one, you know the square root of 4 is a 2, but square root of 6 just stays in that square root. You can't do anything with it. And that's it. That's your answer. Oh, Alex, you might want to grab this one right here. Oh, you might want to grab the paper right there and then a TI-84 calculator. All right, let's take a look at number 3. So here you have a fraction, and we're just going to separate it. So I have a square root of 49 on top, square root of 64 on the bottom. Now I know that square root of 49 is a perfect square because that gives me a 7, and a square root of 64 is an 8. And that is your answer. Okay, so then we have the summary here, product property and quotient property. So these are the theorems you want to go ahead and copy down and memorize. And basically what it is if you have a square root of A times B, that's the same thing of square root of A times square root of B. And similarly with the quotient property, if you have a square root of A divided by B, you just separate them, square root of A over square root of B, just like that. All right, let's go on to the next part. Simplifying means to find another expression with the same value. It does not mean to find the decimal approximation. A radical and simplified form will never have any perfect square inside of it left. So anything that has a perfect square inside the square root, you gotta take that out, okay? So let's take a look at number 4. For number 4, you have a negative here. So I want to separate it like this. So what times what gives me 500, but one of the number is a perfect square. And if you're like, what are my perfect squares? Well, you have it right there. So I'm just going to cut this and move it over to my slide. So that way I have it as well. Okay, perfect. So then your calculator might be your best friend here. So you get to think about, okay, let's put 500 divided by, I would say 25 will definitely work because 25 is a perfect square. That gives me 20. And then I go, from 20, what else goes into 20 that's a perfect square? Maybe a 4. So then the numbers I use is going to be 25, 4, and then 5. So I'm going to put square root of 25, square root of 4, and square root of 5. So in this case, you actually have 3, and that's totally fine, okay, because they still equal 500. Well, you know that the square root of 25 is going to give me a 5. Square root of 4 is a 2. Square root of 5 just stays the way it is. And if I go ahead and multiply it, my answer is a negative 10 square root 5. Okay, number 5. You have a 3, so you're going to ask yourself, what times what gives me a 27, but one of them has to be a square, a perfect square. I look at the numbers up here, and I don't know about you, but I think 9 will work well. 9 times 3 is a 27, and 9 is a perfect square. So my answer is going to be square root of 3, or 9 is a 3. The square root of 3 stays the way it is, and 3 times 3 is 9. So my answer is 9 square root of 3. I'm like, oh my gosh, I'm like really bombing this with the numbers. I'm getting dyslexic with just looking at this. All right, number 6. So for number 6, if you guys take a look at this right here, you have a 3 square root of 12. So what times what gives me a 12? That's a perfect square root. The smallest one I can use is a 4. So 4 times 3 is a square root of 12. But then don't forget your second one right here. And you have a 2 and a square root of 6. So what times what gives you a square root of 6? And you got to be a little careful with that because strategy-wise, nothing goes into 6 that's a perfect square, like 4 and 9. They just don't go into it. But do you see how there's a square root of 3 right there? So if I have another square root of 3, then I can take those 2 3s out because they have 2 of a kind. Okay, so 3 times 2 is a square root of 6. So then my answer for this is you're going to take that 3 that's already on the outside and the 2. You're going to have 3 times square root of 4 is a 2. Bring down that 2 right there. Do you see how I'm just like drawing the little arrows to bring it down? The square root of 3 right here times this square root of 3 right here, because they're the same kind, is just going to give you a 3. If you don't believe me, square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. And then this 2 just stays inside the square root. So then with your calculator, what's 3 times 2 times 3 times 2? That's 6 times 4, so that's 24. Or I'm sorry, that's 9 times 4, that's 36. Square root 2. What's your last name? What? How do you spell it? Oh. Oh, you want to grab a calculator? All right, let's take a look at the last one. Okay, with the last one, you guys have a square root of 7 and a square root of 16. So we're just gonna separate it like that. Well, this is pretty simple. Square root of 7 stays as is. Square root of 16 gives you a 4. And that's it. All right, let's move on to the next part here. So for number 8, 9, 10, and 11, if you look at it, all of them have a square root, top and bottom. So dividing radicals can never be left in the denominator. Like if you have a radical on the bottom, that is a no-no, okay? So how do you get rid of a radical? You must multiply with a radical on the bottom. So what it looks like is you'll multiply this one with a radical, top and bottom, and they'll be the same radical, top and bottom. And if possible, simplify the square root before beginning the process. All right, so let's take a look at number 8. So first thing I'm gonna do is I'm gonna go ahead and split it. Okay. And then once I split this, let's simplify the square root before I move any further. So I know square root of 25 is a 5. And the problem that I see here is I have a square root of 3 on the bottom, and I cannot have that. So how do I get rid of that? What you're gonna do is you're gonna multiply by the same thing. So I'm just gonna multiply by the square root of 3, top and bottom, like that. And when you do that, what ends up happening is the top never changes, it stays exactly the same. But then what's square root of 3 and square root of 3? They're two exactly the same number, it's just gonna be a 3. And if you're like, I don't believe you, how does that work? Well, square root of 3 times square root of 3 is a 9, right? And what's the square root of 9? Just a 3. So if you wanna visually imagine that, that's how it works. So this is your answer. Okay, let's take a look at number 9. For number 9, I'm gonna have you guys go ahead and give that a try. And once again, please put your cell phone away and make sure you're paying attention to this because this is due at the end of class. I'm doing this because I care and I want to make sure that you guys know how to do this. So that way you're adequately prepared for next year's math class. And if you take a look at number 7 here, well, that square root of 2 and 2 just becomes a 2. But then on top, 7 and 2 gives me a 14. And there's nothing that you can do to simplify it. So you just kind of multiply it back together. All right, let's take a look at number 10. So for number 10, let's split it first. And then let's multiply it by the same denominator. Now, when you do that, remember the bottom stays just 5 without the square root. But then on top, you're like, 12 and 5. I know that with the 12, I can do a 4 and a 3, right? And guess what? That 4 gives me a 2. And then you just simply take that square root of 3 and that square root of 5, and you just multiply it. And that's it. There's nothing else you can cancel. All right, and the very last one is number 11. And with number 11, we're gonna look at this. I'm gonna split it, so I have 20 and 27. I know you wanna multiply by square root of 27, but that gets a really big number. So remember it says simplify the square root before you multiply. That would be for this one, because 27, you can definitely simplify it. I'm gonna break that down. So what times what gives me a 27? I could do a 9 and a 3. And on top, for the 20, I could do a 4 and a 5. Now, with the square root of 4, I hope you guys realize that that's a perfect square, and the 9 is a perfect square. So then I'll have a 2 square root 5 over a 3 square root 3. But then unfortunately, I still have a square root 3 on the bottom. I can't have that on the bottom. So then what I'm going to do is I'm going to multiply by square root of 3, top and bottom, like that. And so then what's going to end up happening is that if you look on the very bottom, this square root of 3 and this square root of 3 will just become a 3. So then what is a 3 times 3 on the bottom? It's just going to be a 9. And then on top, 5 times 3 is a 15. And that's your answer for number 11. All right, you guys, let's go on to 12, 13, and 14. And we might not finish all of this today, but that's okay. I have an escape room thing for you guys to work on today as well. And so we'll get started with that after maybe the next 3 examples, and we'll stop there. And we'll finish this on tomorrow. So for number 12, it says, make it easier. Simplify the numbers underneath the radical before rationalizing. All right, so I look at number 12 and I see that there is a square root of 6. I don't like having that. So I'm going to multiply square root of 6, top and bottom. And if you're like, why can I do that? Well, if you multiply a over a, isn't that just 1, right? They're the same. You can multiply anything by 1 because it doesn't change it. And it's legitimate and you're not breaking any math rules or anything. Okay, so then when I do that, then what ends up happening here on top is I have 12. 6 times 2 is also a 12. On the bottom, this 6 and this 6 just becomes a 6. And what's 6 times 2? A 12. Well, I can just cancel that 12, and then I'm left with square root of 12. But then I can also break that down into a 4 and a 3. And 4 is the perfect square root, so I'm going to rewrite this 4 as a 2 square root 3. And that's my answer. Okay, number 13, you guys. For number 13, This one looks a little bit crazy, but that's okay. I don't like the fact that I have a square root of 2, so I'm going to multiply by square root of 2 top and bottom. And then when I'm done with that, what ends up happening is 2 times 10 is a square root of 20. Square root of 2 and square root of 2 is just a 2. So what's 2 times 8? 16. Okay, so then you're like, all right, what about the 6 and the 16? Can I reduce that? You can, because couldn't we divide it by 2 on both? So that gives me a 3. That gives me a 8, like that. So I have a 3 on top, 8 on the bottom, and then square root of 20, you can break it down to a 4 and a 5. So then this part becomes a 2, and what's 2 times 3? 6 square root 5 over 8. And then you're like, okay, well, couldn't I divide it by 2 top and bottom one more time, like back and forth way reducing fractions? Yes, you can. 3 square root of 5 over 4. And that's your most simplified form. And do we have any square roots in the denominator? Nope. So I'm good. All right, last one, you guys, number 14. So with number 14, you have a 10 on the bottom. And so let's multiply by the square root of 10 top and bottom. And when I do that, 8 times 10 is going to give me a square root of 80. 10 and 10 is going to give me a 10. What's that 10 times 2? Just a 20. All right, then we're going to go ahead and figure out, okay, what times what gives me an 80, but one of them is a perfect square. And since 80 is a really big number, I like to use my calculator just so I can see, like, I'm not dividing anything incorrectly in my head. And so I'm just going to put 80 and then go divided by, I think 4 goes into it. That's a perfect square. Gives me a 20. Well, guess what? I can go ahead and divide it by another 4, which then gives me a 5. So my answer is going to be 4, 4, and 5, because that multiplied together gives me 80. So here, I'm actually going to need a little bit more space. 4, 4, 5 over 20, like that. All right, so then do you see how you have 2 of the same kind with the 4 and the 4? That's just going to give me a 4. So then 3 times 4 is a 12. And I can reduce this a little bit further because I could reduce it by 4, top and bottom. 12 divided by 4 is 3, square root of 5. 20 divided by 4 is a 5. And that's your answer. All right, you guys, we will finish up numbers 15 on tomorrow. So I'm just gonna have you guys hold on to this. And now what I'm gonna have you guys do is with your cell phones, okay? We're gonna do an exponent escape room. And so go over to the QR code right there with your cell phone. I wanna grab that right there. Once you get into that, type in your name. I'm going to help you guys out with the first couple of rounds, and then your goal for the next 20 minutes is to finish that and then submit it. So make sure you type in your name so that way I know who you are, and I can give you, like, you know, and that way I can give you the check plus for it, for your participation. So I'm gonna give you guys another minute to get on there, because then afterwards I'm gonna join you as well. Yes. Oh, okay. 1 second. It does exist. I think it was just because it was a bad QR code. So give me 1 second. Thank you for letting me know. Sometimes my little freshmen will literally sit there and keep trying to screenshot it after like 10 minutes. They're like, we don't think it works. And I'm like, well, you should have said something like 10 minutes ago. Like, it would have been fine. All right, let's try this one and see if this one works. Okay, try that one. Sorry about that, guys. Does that one work? Okay, cool. All right. Yeah, I was like, I think it was just a bad QR translation there. So make sure you guys get to that page, insert your name, so that way I can just check you off and get you credit for that. You guys have another 30 seconds, and then I'm just gonna go ahead and get started with it with you guys. All right, so does anybody still need the QR code? Everybody good? Everybody there? All right, so I'm gonna join you guys as well over here. And once I get over here, for those of you guys on Zoom, you should see something that looks like this. So what is your name? I'm gonna type in my name, you type in your name. And then we're just gonna hit next. All right. Puzzle 1, can you simplify each expression and type in the correct code? And then remember, all caps, no spaces, and your code's gonna be in letters, okay? So here are your questions right there on the left. Your answer choices are on the right here. So for number 1, x squared times x to the 5th. Which letter do you think that's gonna be? I don't know, it's gonna be 2 plus 5, so it's 7. So your first letter should be E. So on my answer, I'm gonna type in capital E. And then for number 2, x squared times x to the 3rd. You just add the two numbers, so x to the 5th, and that will be letter G as in goat. Number 3 is a division, so you always subtract the smaller number. So 9 minus 3 is 7. So that's gonna be E one more time. And then number 4, it's x to the 10th times x to the negative 2nd power. So 10 minus 2 was at 8. So that will be C as in cat. So your first code is EGEC. All right, I'm gonna hit next. Really? Keep trying, you can do it. I'm like, I thought I did do it. I'm like, did I do something wrong here? Does anybody see a mistake that I made? EG. Oh, it's 6. It's H. You're right. I subtracted wrong. Oh, duh. All right, sorry. It's EGHC. Just kidding. My bad. That was totally my bad. I'm kind of embarrassed that I did that. I'm like, hello, Callahan. All right, and then next, now we're going to the next one. You did it. You unlocked your first one. Click next for your next puzzle. So next. All right, and then you just continue on. Does that make sense? So this is puzzle 2. And you guys can just continue on working on this until you guys unlock all of the puzzles. To help you guys with puzzle 2, my first one should be x to the 6. So that's A as in apple. Make sure it's in caps. Number 2, it should be x to the negative 3. But when I look at my answer, I don't have a negative 3. I have a 1 over x, the positive 3, and that will be it. So D. And then number 3, I have 1 minus 3 is a negative 2. Negative 2 plus 2 is a 0. So what is anything to the 0 power? I know some people say h, and it's not h. It's 1. So it's going to be I. And then the very last one for 4, 3 plus 0 is 3. 3 times x to the 1 power, it is going to give you a 4. So your next one should be a B. So I think it's ADIB. Let's see if that's right. Yes, we unlocked the second puzzle. So go on to the third puzzle. So I hope you guys are getting the idea of how to do this. So just continue on, you guys, until you are completed. And then at the very end, hit submit.